Happy to be here and spent a lot of time working with Dr. Bilo, like you said. Been here at Illinois, what I like to say, true Illini inbred. But it makes me proud. I'm happy to be a part of this institution, especially because I am from Byron, grew up in the state. I'm very familiar with here, and it's always fun and exciting when I get to do work that goes back to those people that I grew up with, my neighbors, go home, things like that. So really do enjoy it. Just those that may have been familiar with me going through Dr. Bilo's program, and what a lot of Dr. Bilo's students do, they often go to industry. And so I was going to do the same thing. I was going to go down product development, something like that. And in the very last year of my graduate work, got a lot of interest in the trials we're doing, had too many questions, and said, I think I want to try that academic thing instead. And here I am now, just got hired as a research assistant professor. And when you get hired as a professor, they say you're going to do certain things, research, extension, teaching. And they give you some advice, which is always good. I like advice. They say when you teach, there's certain times of teaching that are better than others, right? You don't want to teach an 8 a.m. class. Nobody will be there. You don't want to teach after lunch. They'll all be asleep. I said, that's fine. I can work with that. We'll figure it out. And so we got through all that advice. I was about to leave, and they said, oh, there's one thing we forgot. You're at Illinois. And so the one thing you never want to give a lecture after is Dr. Fred Bilo. Well, here I am. So we'll see how it goes. But really excited about this opportunity. And some of the questions we start to get are tissue testing as part of fertility management. And when we do projects as researchers, we always love when those projects are of interest to our growers. And I can tell you, since we started this project, I think I have had more emails, texts, phone calls about what are we learning before we even started. So that gets me excited and a little nervous, right? So we got a lot of interest in it. But why are we looking at tissue testing? What's going on? Why do we tissue test? I think it's important to look at history of soybean yields. So this is from the USDA. And this is the U.S. average, not the Illinois average, soybean yield. So obviously the green line there is the yield for a given year. Bounces around based on the weather. But that trend line shows us that on average we're increasing yield as a country about 0.4 bushels per acre per year. And so that means yields continue to climb and continue to go. And Dr. Bilo talked really importantly about high yields and high nutrient requirements. So if yields are going up, does that also mean we have higher nutrient requirements? And we can look at a different way to put those numbers on the screen, right? So I went to 60 bushel soybean, following more on our trend line, but the trends are the same, right? So we need a lot of these nutrition. So this is the total amount of nutrition that a 60 bushel soybean crop would need. This is how much removed with that grain. And then you have your nutrient removal coefficients. We can do the math, like we said, we showed an example earlier, but the other thing to also think about is if we're increasing yield 0.4 bushels per acre per year, how much more nutrition are we going to have to do to keep that going? And so there it is. And it doesn't seem like much intuitively, right? And I'll put a note on here. This is straight P or K, so you have to do the conversion for the P2O5 or K2O. So those might look a little low, keeping that in mind. But we need over a pound of nitrogen per acre per year now to keep up with that yield trend. We're going to need over a pound of potassium, half a pound or so of P2O5 equivalents. We're needing more nutrition. And when we think soybean, traditionally, where is that probably coming from? Either the soil or last year's fertilizer from what's left over from that corn crop. And so we can then think about what is in the soil. And you always look at these numbers and you just think, well, why are we fertilizing? Look how much nutrition is in our soils. Thousands and thousands and thousands of pounds. That's in your acre furrow slice, right? But then you look at the amount available. The tricky challenge here is this is how much we need in a single season, and at any given point, this is only how much is available at a time that we might sample it. And these things go back and forth, and they do release over time, but is this enough to get us what we need? And there's some other challenges to that availability. It's not that this is always the case. So if we look at things like nitrogen, phosphorus, and sulfur, those release via mineralization, because they're in your organic matter. And the others, potassium, calcium, magnesium, right, those tend to release via weathering. Now, if anyone here has the perfect model that can predict exactly how much that acre will either mineralize or weather this year, I will sign up today and hopefully be retired in 5 years with the amount of money that would make. It's really, really hard to predict what that soil will release that year. And so when we do soil testing, because when I think about nutrient management for any crop, soil testing, almost every acre, I think it's a soil test every 5 years at least or so, trying to understand what's the soil potential. But that's the total quantity, but there's the temporal components for nutrient uptake demand. And alluding to what Dr. Bilo said, early beans, they grow to a higher yield, but they grow slower, so the rate per day is less. And when we look at the total amount, I think that's when a lot of us think, right? If I have a yield target, I know how much fertility that crop will need. But how often do we think when in the season the crop needs certain components? And that's one of the things that, we've got the infamous nutrient uptake charts. If you're a Bilo student, you know that you're required to at least put one of these in every presentation. But this is the total phosphorus uptake in this case for soybean, and where it's going in the crop throughout the season. So the green is in the leaves, that yellow there is in the stems and the pods, and then that blue is going to the grain. Phosphorus, a lot of it goes to the grain. How many of us are in this room because we liked biology instead of math? Right? That's me. I started as an engineer. I said, whew, that's a lot of math. Going to biology. Unfortunately, there's a little bit of math in biology, and some people that are smarter than I am, one of Dr. Bilo's former students, Dr. Marcos Lohman, he looked at this and said, I can do math. Actually, he could do calculus. And if you differentiate and take the derivative of the curve, you can actually get the daily uptake. Now, this was really exciting, but I also was mad at Marcos because I had to drive 3 hours north to go find my high school math teacher and say, hey, I actually use calculus in real life. Bummer. She was right. But when you do that, when you integrate this curve, you get the seasonal phosphorus uptake. This is amount of nutrition needed per acre per day. And that looks like this. And the thing you'll notice with soybean is there's two distinct phases. The initial growth, when things are kind of going slow, you need less than 0.2 pounds P2O5 per acre per day. But in the peak growth, we're almost needing a pound of P2O5 per acre per day for 60 bushel soybean. Guess what? That number's pretty constrained for the amount needed per day compared to yield. So if you want 80 bushel, that goes above a pound per acre per day. Now, the interesting thing about soybean is it's very different than corn. Corn grows very fast in a short window, right? So those that don't have livestock know that you put the final post-emergent herbicide pass out, and you spend a couple weeks in the Ozarks. And when you come back, your corn crop went from here to here. A lot of nutrition in a short time. You'll notice that soybean is a lot of nutrition over a longer period of time. So not only do we need the nutrition, but we need it available very consistently. And that makes nutrient management hard for soybeans. Say we have a soil A, that can supply this much phosphorus per acre per day. Fertility gets you that gap to make sure we can get to that peak demand. But some of us are lucky and on soil B, or that year's mineralization and weathering is like soil B, turning soil A into soil B. In that case, the soil is supplying all the fertilizer or phosphorus that this crop would need. So when we're out there in the fields trying to look at it, and corn's pretty obvious with a lot of nutrient deficiencies. You could tell when it's deficient in nitrogen, sulfur, phosphorus. Soybean has some similar trends where you can see it, but it's not always as easy to see. So how do you know if your crop is deficient? This is why people tissue test. This is where tissue testing has its role, to try and understand the soil as best we can, but it's unpredictable. Just go straight to the source. Check on the patient and say, how are you feeling today? Are you sufficient, deficient? And then we can maybe make a correction. Because the other advantage to soybean being so extended in its nutrient uptake, that means there's window of opportunity to supplement if you're coming short. And the idea of tissue testing is to provide the nutrient status of the leaf material, because as Dr. Bilo mentioned, most of the leaf assimilates go to fill the pods at that node. So if we know what's going on in the leaves, we can predict that will be going to the pods. And then that's how maybe we break the relationship, right? If we can ensure the nutrient status of the leaf is adequate, and you've set the number, that'll get us the seed weights, or make sure we don't abort pods as well. There are some challenges though. Out of curiosity, raising hands, how many people are tissue testing their soybean? Right? Good, we got some hands up. It's a little less than half, but it's a growing interest, and then you do talk to the high-yield growers, and what do they say? You got a tissue test, and then they don't necessarily tell you what you do after that. Right? So they're really, really good at telling you how they did it without actually telling you anything. But what the standard recommendation is, right, for soybean, most recently matured trifoliate. I think, would nod of heads, people agree with that? Right? Well, I scratch my head and say, what does that mean exactly? How do you define mature trifoliate? Well, you got to look at the soil labs and the plant tissue testing labs. They all have different recommendations. Great resources on there. And if you have your lab, you know what they recommend, but are you looking what other labs are recommending? So WaterZag is an example. On their website, fully developed leaves at the top of the plant. That's how they describe where you should sample. A&L Great Lakes, we work very closely with them. Recently fully developed leaf without petiole. So there's at least a more specific example. We're not looking at petioles, we're looking at leaf material. Ward Labs, they have an initial phrase, 2 or 3 fully developed leaves at the top of the plant. They do go on to be a little more specific. Mature leaves are the 3rd or 4th set of trifoliates below the growing terminals, and the petioles should also be removed. So now we can at least start counting, right? So you go below the bud and you count down 1, 2, 3, 4. We'll take 3 and 4. That's what they would define as mature. Descriptions are often open to interpretation. Some of us are good at learning via audio or reading, but many of us are really better learning with visuals, right? Some of the labs, I'm happy to say, do have visuals for how you should tissue test soybean. So here's Midwest Laboratories, very artistic. And I apologize for those in the back, but they circle the trifoliate they're looking at. But if you look closely, there's 2 lines. One goes there, and one goes there. So it's artistic discretion. Which trifoliate or petiole are they saying that's coming from? Because based on that, it looks like one's at the top of the plant, but one might be in the middle of the plant. Here's another example. Similar thing. I can see 2 clear lines coming from that dark spot where they're recommending. So it's a visual on where to recommend, but it's still a little vague. And then this is a generic for soybeans, snap beans, or peas that they say newest fully developed, and again, we're a 1/3 of the way down the plant. So while there are recommendations, I think there's a lot of variability in how people describe it, and I would say soybean tissue testing and which ones you pull is probably either A, in the eye of the beholder, or B, when you were an intern at some point and your agronomist you were working for said this is how you do it the rest of your life that way, because that's what you were taught. These bring some questions as to how consistent is tissue testing. Now, if you do sample, be sure you do it the same way every time. But if you have a couple of interns and you're trying to do multiple fields, are your interns all sampling the same way? Or when you get different results from different farms, is it because the interns are pulling from different spots? Things to consider when we are tissue testing. How do we sample tissue testing? Going to an actual soybean plant, we stripped everything from the bottom. So this was a V7. Most open right here, right? This is still touching, so that's our 8th trifoliate. 1, 2, or 3, right? So 1's the youngest, 2 is that what I would say second youngest, 3 right here. Which one are you sampling? Are you on 1, the newest, 2, that looks pretty mature, or 3? And with the coloring, you can say these 2, this one's starting to wither a little bit, but color-wise, this is much darker. And we also typically know darker plants are usually healthier, better nutrient status. So is the paler one still not quite at full capacity? Most of us, I think, would select number 2, right? The crazy thing about this is you got 48 hours later and everything's changed. So that challenge there. But how we define most mature, I think, is still a little vague and open to interpretation. And there's still a lot to consider what might be the best strain things, and that's why we're working with the Illinois Soybean Association to go for that, to try and balance the interpretations and make sure the data is most useful to as many that are out there. We're sampling what would say 2 and 3 together. So we're getting the average of what many, I think, would pull, but if some are going, this fits more in that ward recommendation, right? So there's the bud, 1, 2, 3, 3, and 4 would be where their recommendation would be. So when I show you some data in a little bit, this is how we're doing it. We're taking these 2 and combining them to get the average somewhere in the middle on there. So as the crop grows, top of the plant though, that is the consistent thing. So we go out and sample. Maybe we're doing some really early samplings here. We got early tissues, try and get some indication we could put out with the post. But as the crop grows, where do we keep sampling? At the top. We're always going back to the top of the plant. Now it's easy because it's usually easy to see. They're usually nice, fluff, very no insect damage. They're easy to see with your eye. You go in, you pluck them, you walk down the row, you get enough, put them in the bag, good to go, right? So there's that benefit. But what about what's going on down here? There's a lot more leaf material, still green, below where we're sampling. Are we just assuming that those are done? There's nothing that we can do for those trifoliates and we can only fix what's above? Well, soybean has an interesting growth pattern. We say indeterminate growth for most of us here in Illinois. You are still flowering at the top, but developing pods at the bottom. And where this project came from, I had a discussion with a grower I was talking in Kentucky. And they said, when I do my nutrient applications, I've got overcovers, I've got undercovers. And should I change my nutrient management plan based on which parts of the canopy I'm going through at a given point in the season? And I said, that's a fantastic question. I got no idea. Let's go find out. So put the proposal together, started working on it, Illinois Soybean Association. But this is the exciting thing about soybean. It's doing two different things, and we're always focused on what's the newest. I should reiterate, why do we sample the top of the plant? It's the newest growth. And if you are deficient, you would think it would show up in the newest growth because that's where things are pulling from. And at the bottom, maybe we're done. And so is the top the best approach? It is important to still know what the future pods are going to need. Don't overlook the value of that tissue sampling. But are we limiting our yield by ignoring what's going on below? And is our yields not going up because we're losing it on the bottom half, even though we're watching it and managing it on the top half? All that comes together, a review of kind of confusions out there. How should we do it? What's the opportunity and strategy? And so working with Illinois Soybean Association Field Advisor, we've got some preliminary data from our first year. We're going to have a lot more data coming for this 2025. So the one thing I will say as we go through this, I do not promise to have all the answers today. And that's good because I still need to have a job, right? If we had all the answers, I'd be out of a job. And so excited, though, about what we are discovering, where we're going. So a little background on our approach and how it started. So started here at Champaign. We used, here's our standard soil test. Pretty good on the P and the K, I'd say, from our understandings of recommendations. Probably not going to be supplying fertility for this soybean crop, corn crop. We might be pushing it for a little bit. But good base, good solid sound start. A longer maturity variety. We want to extend the season, get good leaf health when we're doing leaf tissue samplings, and understand a little bit of that remobilization. Standard planting rate and wide rows. But we did go a little earlier, April 22nd. One of the questions about tissue testing is there's the soil supply that we talked about, but what if you fertilize and make sure you're already ahead of the game trying to minimize the potential deficiencies? So we looked at this in two ways. No fertility, that's soil supply, or we put out a full broadcast rate of NPK, sulfur, zinc, and boron at rates for targeted yield goals of 60 bushels, just to make sure we were trying to cover our bases. I will give you the yields right now. First of all, it was a pretty good year for us on this site. So soil supply was 85, and we did get about 7 bushel response to the fertility. Moving forward, though, I think many of us are maybe not fully fertilizing soybeans, so the interpretation of the soil test is, or the tissue test is, what's the soil providing or not providing, and then we correct for that. So making up for the soil lets down. So the rest of the inference will be to the unfertilized plots for today. Again, like I said, how we sampled it, this would be like a V7 trifoliates. If you count back, you got cotyledon node, your unifoliate node, and then you start counting. We took 6 and 7 together, so there's 6, there's 7. Now at this stage, that's the standard, the most recently mature for this timing. Where we changed it up, going back to the title, taking tissue testing to the whole plant level, here is a V11 plant, where we came in and we sampled trifoliates 11 and 10, but we also came back and pulled 8 and 9, and 6 and 7. And what's cool about this is we took 6 and 7 at the 7th V7 vegetative. We took 6 and 7 and 8 and 9 when we had 9 vegetative trifoliates out there, and we come back. And so we're constantly tracking what's the lower canopy doing over time as the upper canopy builds. And then I will just put a note, anything 5 or below, we didn't. There's some herbicide injury, and a lot of those drop off and don't put pods at all, or they branch. So we ignored the branches as well. We focused on the upper half of the stems. Love working with data. And even better is trying to summarize data in a way that we can all think on and move through. So this is going to be what we tend to avoid. It's common format, but what I want to explain how we design and sample. So what you have is which trifoliates we collected on that y-axis, and then you're going forward in time with the vegetative and then the reproductive status at the day we sample. One of the crazy things about early beans, they will flower before June 21st. So the reproductive phases here too, it changes traditionally, right? We think we had flowers, V7, and I think our first sampling was somewhere around June 11th or 12th. So just understanding that. But with tissue testing and tracking it, we focus on the trifoliates. And the other thing is we went every 2 growth stages by pairs. I know a lot of folks will go out every Monday, get the results by Wednesday, make an application, and then do it all over again. We wanted to track the same trifoliates because you're not guaranteed, maybe you got 1.5 growth stages in a week. This week it was 2. Really slow week, it was 1. So keeping in mind there, it wasn't on a consistent time basis. We tracked every 2 leaves to emerge to keep that consistent. What I will first show you is the biomass in that, what an acre furrow slice, right, on a soil test is. Thinking an acre furrow slice on that level of the canopy and how much nutrition is in that level of the leaf canopy. And this would be the biomass for the standard recommended timings. So if you got a V7 plant, you're taking those top 2 nodes. If you got a V9 plant, you're taking the top 2 nodes at that stage, and so on and so forth. This would be what would be standard recommendation in the data. And we actually weigh these and then calculate the biomass per acre. The interesting thing is the top of the plant, between that 9th to 17th or so trifoliate, it's basically the same size. So during the majority of the season, the trifoliates themselves stay consistent. They're not getting bigger in certain parts of the plants or smaller. Obviously our early season and our late season growth, we know those top trifoliates will never be as big. So that was an interesting finding. So when we think about comparing tissue tests from sampling to sampling, the biomass stays consistent. But what happens when we go back about 10 days later? There's the biomass of those same trifoliates, but at the next sampling, and they all increased. Now, does this mean they all got bigger in surface area, or maybe it's leaf thickness? They're just getting thicker. But our most recently mature, 10 days later, are still getting mature. So it also comes back to defining maturity. Is it based on how open those trifoliates are, how dark they are, or when they reach peak mass before they start to remobilize? And so in every single case, we actually had biomass accumulation continuing, and these would be the 4th or 5th trifoliates below the newest bud. So you go to the bud and start counting back. Would be peak biomass, and is that how we should define most mature? And I'll use this example. Again, the standard test should say we're pulling the red circles, but based on peak biomass, that didn't happen till 4th and 5th down. So do we need to thinking, should we be sampling a node or 2 lower to get the peak biomass and development of that trifoliate? If you take it out even further, there's some interesting trends. It would suggest that the bottom half of the canopy is starting to then get smaller, starting to remobilize to those pods. The upper part of the canopy in a few spots continues to grow. So there's a spatial difference in how the trifoliates go. And on this data, it looks like the lower canopy loses its biomass a little quicker, and the upper canopy still goes. Makes sense though, right? As soon as it starts to shade out, we know those lower leaves start to wither, drop, and go fast. The upper leaves are still going. So that's the dynamic of canopy sunlight interpretation. But the tissue test would say do the same way no matter what stage you're at. Questionable there. This is if you do it all out, right? So there's no data up in this corner because eventually those 6th and 7th trifoliates are no longer there. And then obviously there's no data here until you have those nodes developed. This is circling at what time a certain set of nodes did peak in biomass. And so 1 year data, like I said, a little bit, trends, it's not perfect, but what it does suggest is that the lower canopy is maturing more quickly, i.e. 14 days, and then it goes downhill. And the upper canopy might go 21 days before it's fully developed and starts to remobilize. So there's different spatial implications there. And why this is important to have this discussion. Tissue test is a nutrient status of leaf material. How many of you, though, weigh the tissues and compare that to the tissue test? Because a large biomass can have a low concentration because the nutrients are distributed over a bigger area. A small biomass can have a high concentration. We did our high yield Quest studies a couple years ago, and our all-in 500 bushel Quest corn had lower soil tissue tests than our standard because the things were twice as big. But if you did the uptake and actual nutrition in the plant, it was higher. So this is why tissue test also has some variability because the biomass changes the results as well, and that's why it's important to maybe try and collect both. So then, though, these are the values most of us probably familiar with. They range. These are from A&L. That's the same lab that's running our samples, and so we wanted to go off their standards. The first thing you'll notice on the macros, there's quite a range there, and they change it slightly based on stage, but that's quite a range, and it's even more of a range on the micros. I mean, boron, for example, that's a 3-fold difference in the lower to upper threshold. So if my tissue test for boron is 25, on one day and 55 on the next day, is that still sufficient? Who's setting the standards? Where are those data coming from? Is it outdated? Is that for 40 bushel beans and now we have 80 bushel beans? We need to update this. So again, these are what the commercial lab levels are, but it's what we can use as a reference in our data set. So here are the nitrogen concentrations for all those trifoliates and all those times. And there's a few key trends going on here. If you look within one set of node and go left to right within a row, it gets less. Every time. That row gets less from left to right, left to right. So left to right, nitrogen decreases. Left to right is time. Time from when that trifoliate first emerged to when it eventually withers off and has been remobilized and falls off. I don't think this is shocking, right? It's putting data to stuff we see in the field. Over time, the leaves get deficient and move that to the pods. What's also interesting, and again, not really, I would say, groundbreaking, if you go from top to bottom, i.e. newest trifoliates to oldest trifoliates, the concentrations also decrease. New growth is where we're putting most of our nutrition. Old growth, we don't really as interested anymore from the plant perspective, or it's remobilizing it. So these are key trends that just has the data, backs it up, makes sense to what we see. So newer trifoliates have higher nutrient concentrations as the lower nodes have started to remobilize. And then the interesting thing, though, is here is what would all be considered sufficient. And I use a cutoff of 4. So from a nitrogen perspective, we were probably good the whole season long. Nitrogen wasn't limiting in this case. However, going back to biomass, if you multiply this concentration times this biomass, you actually get the amount of nutrient in the leaf material. And they almost all peak right at the front. So the tissue test says sufficient, but very clearly we are moving nitrogen somewhere else on an uptake basis. So maybe, again, the critical levels aren't maybe adapted to today's yield levels. So tissue test sufficient, yet nitrogen is moving left to right through time. It's leaving the leaves. Why this makes sense, nitrogen uptake is season long, and a lot of it goes away from the green into the blue, remobilization. Phosphorus, this is interesting. Phosphorus, we were basically sufficient every time we did the most mature, but the next sampling, all our lower trifoliates were deficient. And so phosphorus is moving very fast out of the trifoliates. And phosphorus, why is that going on? 80% of phosphorus does end up in the grain. And so as soon as it's in the leaf material, maybe it's thinking, I got to go to those pods, and phosphorus might move a little more quickly than nitrogen. Sulfur is an interesting case. We get a lot of things on there, right? So sulfur also goes to the grain. Should it act like phosphorus? Well, if you look at the trends, the lower canopy moves sulfur out of leaves fast. The upper canopy tends to build it, and then, or middle canopy, I should say, builds sulfur, then removes it, and the upper canopy holds on to it. So now we have very clear different patterns in N, P, and sulfur. But we're still recommending to sample the same leaves for all nutrients every time. I would challenge that, and that's what this project is focused on doing, and eventually it does go down. So sulfur levels change over time and is canopy position dependent. Boron, I'll just cut to the chase on boron. There's the leaf test and the uptake accumulation. It's more or less steady. A lot of these values don't change, right? They dip a little bit here and there, but you don't really see much boron leaving the leaves because boron doesn't leave the leaves, right? It's season-long uptake, but once it's taken up, once it ends up where it goes, it stays there. So also understanding boron in the leaf tissue test may not be as useful for a grain perspective because it doesn't end up moving from that grain point. And so soybean doesn't remobilize the boron. Different thing there. So really excited to just bring what we're starting to learn, like I said, still have some answers yet to get to, like I said, keeping us in business. But what we're tending to see is the newer leaves certainly have higher nutrient concentrations than the older. The lower canopy maybe matures a little more quickly, and that trifoliate selection probably is going to depend on where we're at in the crop. And for the nutrition, it's different based on which nutrient. Certain nutrients move faster than others, and it's spatially dependent. Probably have a lot yet to go to optimize nutrient management in soybean. And maybe 0.4 bushels per acre can become 0.6, 0.8 bushels per acre per year on that increase. However, last question I get. So what's your recommendation based on current tissue guidelines from the labs today? Well, innocent until proven guilty. We haven't nailed it yet. Current recommendation would still stand. However, maybe go one trifoliate lower and see if that gives you some better results and responses. Do some comparisons side by side. What you typically do, going one lower, change the recommendations if you're doing foliar, and really consider where you're pulling from. So thank you very much, Field Advisor, for this event, and Illinois Soybean Association for the project, the sponsor, and the opportunity. I know I'm right up on time, but I'm not running away, so I'll be around for the break. Thank you very much.